Welcome to this explainer. Okay, today we are going to completely shatter this illusion of the immaterial cloud. We're pulling back the curtain to reveal the hidden, highly physical empire that's actually running our digital world. You know, we often think of our digital lives as this weightless thing, just existing in some abstract space. But as you'll soon discover, the reality is built on heavy industry, massive capital, and intense human labor. So get ready, because this is absolutely going to change how you see the internet forever. Okay, let's dive into this. For decades now, we've basically been sold the myth of a magical, weightless internet. You know, a fluffy cloud where our data just seamlessly floats around. But the shocking biophysical reality is that the digital realm is essentially heavy industry. It is profoundly reliant on raw resource extraction, endless miles of fiber optic cables, millions of tons of concrete, and massive, incredibly power-hungry data centers. The digital world is literally just as physical as the Industrial Revolution was. To truly understand this, we're going to unpack this massive empire layer by layer. First up, the new infrastructural power. Second, the techno-financial ecosystem. Third, we'll look at the materiality of AI. Fourth, invisible human labor. And finally, toward digital sovereignty. All right, section 1, the new infrastructural power, from institutions to infrastructures. So over the last 30 years, power has quietly shifted. We evolved super fast from basic 90s digitalization to the platform gatekeepers of the 2000s, right into this massive 2010s convergence of tech, state, and finance. And now, in the 2020s, we've reached full-blown systemic dominance, where a few private architects effectively govern the global economy and the flow of information. Moving into section 2, the techno-financial ecosystem and the intertwining of tech, capital, and defense. Now, what's really interesting about this slide is that it shows this isn't just about tech companies anymore. It's a deep structural intertwining. Just look at the staggering wealth of the Magnificent Seven. By 2026, estimates project their combined market cap is going to hit $19.4 trillion. That's trillion with a T. They control the cloud, the AI models, and the microchips, making up nearly a third of the entire S&P 500 index. It's a concentration of wealth and power that's honestly almost unprecedented in modern history. But here is the real hidden engine, $25.3 trillion. That represents the combined assets managed by just the big three financial funds, BlackRock, Vanguard, and State Street. Through a practice called common ownership, these three funds own anywhere between 15 and 23% of those exact same tech giants we were just talking about. So the tech platforms might run the physical infrastructure, but these financial giants hold the keys, heavily influencing corporate strategies and global resource allocation. And this naturally brings us to the techno-military complex. The exact same dual-use technologies, like those advanced NVIDIA chips, well, they power both civilian AI systems like ChatGPT and military applications, like autonomous drone targeting systems used in modern conflicts. On top of that, you have massive initiatives like the proposed $500 billion Stargate project in the US, pushing for immense deregulation just to rapidly build data centers for both commercial and strategic dominance. Let's move to and see how this builds into section 3, the materiality of AI, beyond silicon toward heavy industry. Notice the stark geopolitical concentration of computing power here. Right now, 45% of global IT capacity is sitting in the US, 20% in Europe, and 12% in China. But here's the crazy part. The entire world relies on a very tight, super fragile choke point. The US designs the most advanced chips, TSMC in Taiwan physically manufactures 90% of them, and ASML in Europe builds the incredibly complex $200 million machines required to make them. If any one of these nodes fails, the whole system just stalls out. And then, of course, there's the massive energy requirement. By 2026, global AI energy consumption is projected to blast past 1,000 terawatt hours. Just to anchor those staggering numbers for you to really put that into perspective, that means AI's energy demands will actually match the electricity consumption of the entire country of Japan. It is putting an absolutely unprecedented strain on global power grids and driving a frantic race for new energy sources, even including nuclear power. But we also have to consider the water footprint of AI. All that intense computing generates an unbelievable amount of heat. A single hyperscale data center uses 3 to 5 million liters of water every single day, just for its evaporative cooling towers. That's literally equivalent to the daily water consumption of a city of 30,000 people. This dynamic is leading to what researchers are calling digital gentrification, where local communities lose access to resources while profits just evaporate to global tech hubs. Which brings us to Section 4, Invisible Human Labor, the ghost workers of artificial intelligence. Because while we sit back and marvel at these supposedly autonomous algorithms, we absolutely have to uncover the human supply chain behind them. Researchers refer to this as the diffuse factory, or AI colonialism. It's a globalized system where the global north extracts the technological and financial value, while the global south is left to perform the most grueling, repetitive, and severely underpaid microtasks required to actually train these models. The supply chain of data is just deeply, deeply asymmetric. The human toll behind this system is devastatingly clear. In Kenya, workers are engaging in toxic content moderation for just $1 to $2 an hour, suffering immense outsourced psychological trauma as they filter out the absolute worst content on the internet. In Venezuela, a severe economic crisis drives survival microwork for literal pennies an hour. Meanwhile, over in Europe, we see high-paid, qualified cognitive auditing. It's a highly stratified global labor pyramid.
So the crucial point is AI isn't autonomous. Not really. It relies entirely on something called RLHF, or reinforcement learning from human feedback. Through microtask platforms like Scale AI, thousands of human beings are constantly evaluating, ranking, and correcting the AI's responses to make sure they align with human expectations. They fix the logic, they correct the tone, and they ensure safety. Without this constant, ongoing human intervention, the AI would be essentially useless.
Finally, Section 5, toward digital sovereignty, reclaiming control of infrastructures. So, with all this incredible power concentrated in the hands of a few tech and financial giants, how do we, as citizens and nations, actually reclaim our democratic power in digital sovereignty? Well, we're standing at a major crossroads with two very distinct paths. On one side, we have a trajectory of dependency, where nations just continue to surrender their data and infrastructure to private foreign entities. But on the other side, there's a trajectory of democratic reconquest, fighting back through strong, clear regulations like the European AI Act and making strategic public investments in local cloud infrastructure and semiconductor manufacturing. And the good news is that technical solutions are emerging that shift the industry away from those massive resource-draining data centers. We're seeing an exciting move toward a frugal AI model. This includes using small language models, improving algorithmic efficiency through a process called quantization, processing data locally via edge computing, and powering these localized networks with renewable regional microgrids. It's decentralized and way more sustainable. And this brilliantly illustrates the path forward. Step 1, decentralize with small language models that literally don't need a supercomputer to run. Step 2, compress the data. For example, recent technical breakthroughs can shrink a model like Mistral 7B from a heavy 28 gigabytes down to just 1.5 gigabytes. That's huge. And step 3, process that data locally using edge computing. These steps drastically cut our dependency on those massive energy grids and water supplies. Ultimately, it all comes down to the physical consequences of our digital world. And we have to end by asking ourselves this provocative question. Is our precious water meant to cool AI servers or to quench the thirst of our cities? It perfectly summarizes the physical toll of this technology, leaving us to really question the reality of our digital lives. Thank you so much for joining me on this explainer. I hope it empowered you with some real knowledge. And I'll catch you next time as we keep exploring the hidden systems that run our world.